This is a recorded version of my presentation for SQL Saturday number 332 in Minnesota, A New Frontier of Government and Open Data, What It Means to You in Microsoft BI Tools. SQL Saturday 332 is at full enrollment and there's a long waiting list for people trying to get in, so I'm putting this video together for anybody who was unable to make the presentation. My name is Greg Beaumont and the presentation is for October 25th, 2014. A little bit of background information about myself. I've worked on the Microsoft BI stack since 2007. I've been using Excel since 1998 when I was exposed to it for my undergraduate thesis. And I've been consulting for GNet Group since 2009. I attended St. Mary's University of Minnesota, where I received a Bachelor of Arts in Biology Pre-Med. I also attended the Carlson School of Management at the University of Minnesota, where I got an MBA. And most importantly, I'd like to point out that as a business intelligence professional, I've engaged in quite a bit of self-directed learning. BI is one field where if you put the time in, you study, and you work hard, you can get ahead and you can develop a valuable skill set that you can use to build yourself a great career. My Twitter account is @grbeaumont. I will follow back if you follow my profile. And I also have a LinkedIn account if you'd like to network. We'll start off the presentation by talking about the history of open data, what its current status is, and then give some examples of where you can find it. We'll move on to the Microsoft BI tool stack and how that can be used in order to leverage the power of open data. And then we'll move into some demos of how you can actually use real open data within the Microsoft BI tool stack. So we'll start off with the OpenFDA API, and we will use Power Query to pull that data into Excel. Then we will move to the Seattle Real-Time Fire 911 Calls API, and we will also pull that data into Excel using Power Query. Then we'll go ahead and take a look at it with Power Pivot, Power View, and Power Map in order to plot that data, take a look at it, slice and dice it, analyze it. And then thirdly, we'll take Chicago crime open data and we'll mash it up with Chicago weather data in order to see how the two data sets relate to each other. So we'll take a look at that mashup in Excel, Power Pivot, Power View, and then we'll also build a machine learning model in Azure ML. We'll then move on to some ideas for the future of open data, where it's going and what it means. And then I'll provide some recommended links that you can utilize in order to get kickstarted with your own analysis of open data. So what is open data? The best definition that I was able to find is that open data and content can be freely used, modified, and shared by anyone for any purpose. The source of that definition was at opendefinition.org. There's quite a few different definitions of open data out there. They all basically get to the same point, which is that open data is information which should be completely transparent and available for people to use for any purpose that they deem useful. So when it's out there, you can download it, you can make calls to it, you can effectively integrate it into your solutions, and if it's called open data, theoretically, it should be something that you can do so without any types of limitations or restrictions. Historically, there's all this information over the last several decades which is building up inside of servers, which is being collected from scientific studies, and which is basically being siloed in all of these different places. And the first community to talk about the possibilities of open data was several decades ago. The scientific community said, hey, we have all of this information that's being collated on different types of scientific studies, and wouldn't it be great if we could eventually tie that information together and use it to find newer and better insights into some of the topics that were studied. Then as we moved into the 2000s, there was a movement for governments to be more transparent. Since tax dollars are effectively paying to collect a lot of this information, perhaps the taxpayers should have a right to see it and to use it. And not only is it a matter of getting what you pay for, but it's also a matter of, hey, if they expose this data, third parties can take it, they can make sense of it, they can find new insights, and then they can use this information to basically benefit the country, the organization, the city, the county, whoever it is that's making this data public. So it's a way to say, here's a lot of the information that we've been collecting, and go ahead and use it and see if you can do something good with it. The future looks very bright for open data. As business intelligence and reporting tools get better and the technology advances that are driving those tools, and more data is out there from more countries, from more cities, from more organizations, from more counties, there's going to be a greater ability to pull that data into solutions, integrate it, sometimes mash it up, find data that relates to other data sets, and to effectively find new insights from that information. So there's going to be a lot of opportunities down the road that arise out of this open data movement. And as I mentioned, open data is definitely going global. When I first presented on open data back in 2011, there were a handful of governments that had formal websites where you could actually go and download that country's open data. Now there's data coming from all over the world, not only the US and a few select countries in Europe and Australia and Asia, but there is open data on every continent, with the exclusion of, I think, Antarctica maybe, and cities, organizations, the United Nations. There's open data from the World Bank, and it's a tremendous movement, and it's definitely gone global. There are more great examples of open data sites out on the internet than I can even begin to review in this presentation. I've listed a few of my personal favorites, and I've chosen them just because I have some experience with them and I think they provide some fantastic data. We can go ahead and move to the internet to take a look at a few of those sites. Data.gov is the official home of the United States government's open data. It's effectively a portal that shows you all of the different types of open data that different federal institutions are making public. You can click on a topic such as agriculture, and within that topic you can move to data, and then you can start taking a look at some of the types of things under that category that are available for you to download, to use, and to integrate into your solutions. Another site is the United Kingdom's version of data.gov, and it's very similar to the US version. It's just UK data instead of US. There's also the Australian version of data.gov, and once again, very similar format, very similar types of information. This Socrata site, Socrata is a company which offers platforms for governments and organizations to make their data public, shows some of the different cities around the United States that have their own unique open data sites. So you can see that this is a movement which is definitely taking off in the major cities in the US and even some of the smaller ones. Additionally, it's taking off in Canada. You can see that there's a Socrata site up here in Edmonton. Additionally, organizations around the world are making their data open. So the World Bank has numerous data sets which you can use, access, browse, download. Also, the United Nations has a lot of data out there that you can use, integrate, browse, and it's very impactful data from a global standpoint. I also included here the CBio portal, which is made public, looks like by Memorial Sloan Kettering Cancer Center. And this open data is basically scientific data about cancer genomics. And I just wanted to include this to show that not only is it just government type data which is out there and which is public, but there's also scientific research data. And hopefully by making this data public, researchers around the world can share their findings, and they can more quickly and with a more agile methodology build upon the work that other researchers have done around the world in order to make discoveries faster. Since we're doing this presentation in Minnesota today, it's probably a good idea to note that Minneapolis will soon be having an open data portal. The city of Minneapolis passed an open data policy this July. If you follow the link on this slide, it'll take you to a document about that announcement. And within Minnesota, there's a group called Open Twin Cities, and it's a group of citizens involved with open data in Minnesota. You can learn more about their group and meetings if you go look them up at meetup.com. They have a website, opentwincities.org. I've been to a couple of meetings. I haven't been involved with the group as much as I'd like to at this point, but there's definitely some interesting and innovative things going on within that group. For example, there's a group within Open Twin Cities that's putting together an API store, which will effectively allow for governments to have a framework by which they can make their data public and track its usage. Let's take a look at how you can use open data with the Microsoft BI tool stack. Let's say that you have a report that you'd like to build using Chicago's open data, which is available at their open data portal. It's fairly easy to either build a report on the portal or to download the data and using some basic data manipulation tools, build out a few reports. The same could be said about weather data, which is available out there on the internet and which you can download for the city of Chicago, for the different airports in Chicago, for a lot of different locations around the US. It's pretty easy to download that data and then build a report. Now, what if you have a requirement, or what if we're just interested to combine data from the city of Chicago and also from NOAA in order to compare how weather and crime data relate to each other? That's a little bit more challenging. And that's where you have to have some business intelligence skills in order to be able to mash that data up and build out a reporting solution that allows you to compare the values from the different data sets. Let's take a look at how the different business intelligence tools that are offered by Microsoft can suit the needs of different users. Down at the bottom, you'll see a bar that goes from left to right, signifying all the way to the left being the tools which are for more personal users and which people are going to be very familiar with and require the least amount of training, and far to the right, the tools that require more training and expertise in order to master and to integrate data into for reports. So on the left, you'll see we have Excel and Excel services, and a lot of people are very familiar with Excel. They're familiar with how it works, what the format is, and Excel in 2013 does have some very powerful business intelligence tools, which you'll see later can be used to integrate open data and to work with that data. Next to the right, you'll see Power View, Power Pivot. These are generally built into Excel. Power View is also available on SharePoint, but within Excel, you can use Power View in order to build very rich data visualizations that are fantastic for presentations and fantastic for visualizing trends. Power Pivot is a way to crunch massive amounts of information and to create relationships that mash up data from different sources so that you can have integrated reporting solutions. Microsoft SQL Server and reporting services requires more knowledge of how to write code in SQL, and you have to have a little bit more understanding of how servers work and how reports are built at the most basic level without just using a GUI with drag and drop functionality. These tools can be used at more of a team and enterprise level in order to build more massive solutions with larger amounts of information. Additionally, there's Performance Point, which you'll see all the way to the right, and that's a dashboard design tool, which is generally used for enterprise-type dashboarding solutions. So with Microsoft SQL Server, there's generally a strategy for interpreting how the different tools can use, which can be summed up in personal, team, and organizational business intelligence. At the personal level, individuals want to bring information onto their laptop, they want to explore it, they want to find relationships in it, and they want to start building out some reports in order to figure out how this data can either meet their needs or meet the needs of the organization that they are working for. At the team level, tools such as Excel, reports such as those built in Power View, and data models that are built in Power Pivot can be published to a tool such as SharePoint so that the findings of the individuals can then be shared with the team. You can also do version control and additionally build reports on SharePoint in order to use them as group dashboards or team dashboards. At the organizational level, once the appropriate relationships and types of information within data are established, things that are found at the personal and team level can then be migrated to the organizational level so that those findings can be shared and the value of those findings can be leveraged by everybody within an organization. Those would be services such as analysis services where you could do OLAP and tabular solutions. And additionally, you can use SharePoint with dashboarding solutions such as Performance Point in order to build out some organizational dashboards. The demonstrations I'll be showing primarily focus on the Excel family of tools. If you don't have a copy of Microsoft Office, you can go get a standalone copy of Excel for around $100 on Amazon. And within that, you'll have the ability to use Power View and also to use Power Pivot and also Power Map. And you can start doing some of your own business intelligence mashups and reporting. I don't know the exact price at this time, but I purchased my copy last spring for approximately $100. Within Excel, you have Power Pivot, which is the data mashup tool. Effectively, you can build your own cube type solution right in the back of Excel. So instead of having a limit of, say, 1,000,000 rows within an Excel worksheet, you can have tens of millions of rows, if not more, inside of a Power Pivot solution, which then is able to relate to other data tables within that solution in order to do mashed up reporting. Additionally, there's Power View, which, as I mentioned earlier, is for a rich data visualization experience. It's also a drag and drop tool with a pivot table type interface that is very similar to Excel. Then you have Power Query and Power Map. I'll show a little bit of Power Query later on in the demonstration. But with Power Query, you basically get ETL type functionality at the personal level. So you can pull information in and work with it and mold it to formats that are going to suit your needs. Power Map is a new and very powerful way of visualizing things on a map, and we'll show that too. So once again, how those tools fit into the SQL Server continuum is at the personal level. You use a tool like Excel to pull in data, mash it up in Power Pivot, and then visualize it in tools such as Excel, Power View, and Power Map. You can then publish it to SharePoint to share with the team, where those Excel and Power View dashboards can be looked at, modified, and shared amongst your colleagues. And then at the organizational level, you can migrate that data to analysis services and possibly even integrate it with some of your own enterprise data in order to get new insights into different types of things that are affecting your organization. As I mentioned before, Power Query is basically ETL for personal BI. That's how I like to think of it. You can connect to numerous file types and connections, whether it be different types of flat files, text files, Excel workbooks, different types of databases such as SQL, Azure, Oracle IBM, MySQL. Additionally, it will connect very easily to OData feeds. You can also work with APIs, and there's also the ability to hook up to tools that allow you to access big data solutions. Within Power Query, you can transform, filter, unpivot, concatenate data. You can basically do a lot of the different things that you would traditionally do in an ETL tool, such as SQL Server Integration Services. Once you've decided how you'd like to model the data that's coming into your Excel workbook, you can then go ahead and import it and then specify that it will be part of the data model in Power Pivot. So let's go ahead and move on to an actual demo for Power Query in Excel. This demo is going to pull data from one of the FDA's APIs, and this data is from their new Open FDA portal, and the API is for their Adverse Drug Events database. So we'll be able to pull some information in from that in order to show you how Power Query works. The URL used for the API in the demo is the one that you see here on this slide. And by looking at it, if you've written URLs before, you can see that it specifies a count of events. If you've written API URLs before, you can see that it specifies a count of events by the receive date between January 1st, 2004 and January 1st, 2016. You can explore other types of parameters that you can pull in from this API at this link. So I encourage you to explore that if you want to try out this API. You'll see that there's actually some examples here that you can use in order to get started and to figure out how the API works. But moving down the list, you'll see that there's a lot of different things that you can do. You can get a key if you want to be making frequent queries in order to implement this, say, inside of a healthcare solution or something like that. Let's go ahead and move to Excel. I've already set up the Power Query pull using the API, but we can go ahead and take a look at it here by hitting Filter and Shape. First, I should note that Power Query is a plugin for Excel, and you can see it's actually up here on the ribbon. So there's different ways that you can pull in information using Power Query, and in this instance, we went ahead and set up a pull from an API. So let's hit that Filter and Shape button. And what you'll see here is the results of the API pull. So you'll see a integer version of the date here in the first column, and then just a simple count of events in the second column. Over here you can see the steps that we went through in order to get to that. So if we double click on source, you'll see where that URL that contains the API parameters from the slide is located. And then you can also see how we took that API and we turned it basically into a table, which can then be brought into Excel. And if we go ahead and refresh it, if there's any new data sitting on their database, Power Query will reach out and pull that in. You'll see that the data is actually loading, and as the API actually makes that call, you'll see that at 6:26 p.m., 3,317 rows were downloaded. So effectively, that's how Power Query works. There's a lot of other very useful types of transformations that you can do with the data as you're pulling it in, but it's very simple. It's built into Excel, and it gives the end user or the personal user an ETL tool that they can use. If we move here to sheet 3, you'll see that we just take that simple pivot table and we add it to a Power Pivot model, and then you can start doing some interactive reporting on the data that you've pulled in. So you'll see here that there's a slicer for year and quarter, and using a date table, which was also brought into the Power Pivot solution, we were able to create date aggregations. So you can see that, for example, in 2012, you can open it up, look at number of adverse events by quarter, open that up and look by month, and then down to the day level. And you can also see the graphs over on the right hand side. And if we wanted to look at, say, just 2010 through 2012, we can remove 2009, and you'll see that on the pivot chart in both charts, 2009 has been removed. Looking in the bottom right, you'll see the average daily adverse events by calendar month. If we only wanted to look at quarter 1, we could go ahead and hit that, and you'll see that it only shows the 3 months that are in quarter 1. So let's move on to another demo. This one will also use Power Query within Excel, but it'll be looking at an API that is labeled as being in real time. And what they define as real time is that the underlying database is updated every 15 minutes. So the data in this demo is from Seattle's Real-Time Fire 911 Calls API. And I can go ahead and click on the link to show you what the interface looks like at the portal. And effectively, this is a Socrata site that is being hosted for the city of Seattle. And you can see that there's some information in here that's showing the most recent 911 calls that were routed to the fire department. And over on the right hand side, under the Export tab, you can see that there's different ways to export this data. What I'll be using within Power Query is the SOTA API. And one nice thing about the SOTA API is that there's quite a few open data platforms that are using the Socrata platform, and the SOTA API works basically the same way for the different data sets that are out there. So moving back to the PowerPoint presentation, you'll see that the URL used for the API that I call from Power Query is the one that's listed here on the slide. And basically what it's looking to do is it's looking to pull the most recent 300 events where the date time is greater than July 1st, 2014. I just arbitrarily put a date in there so that it filters to a smaller set before selecting the most recent 300. The URL will basically then reach out to the Seattle servers and pull that information in. There's other parameters for that API and for the Socrata API in general. And this is a great place to start if you want to learn about how to use APIs for pulling in open data. A lot of information and documentation here, and it's pretty easy to learn once you get the hang of it. So moving to the demo, you can see that this was last updated on October 20th, so a few days ago. Today's the 23rd. If I move to the Filter and Shape tab, which is what we did with the other API, you'll see a preview of the data that was brought in at that time, along with a custom column that I created. And what I created here was a custom column that's just looking at date and time in a standardized format rather than the GMT date time, which is coming in, the date time that contains time zone information, which is coming in from the query itself. So if I open up source, you can see this is where the API URL is. Went ahead and specified that the first row is the header, so you can see then in the preview that that the first row becomes the header. I removed report location. That wasn't needed for what I'm working with. That was one of the columns. And then I inserted the custom column, and change the type of it to a regular date time type column. So we'll go ahead and hit done. And once you're here, I'll hit refresh, and you'll see the date time change from the last time I refreshed it to the most recent 300 that are in the underlying database. And you'll see that over here on the far right is the date time that we'd be looking at it in, and it's currently looking at about 7:30 today, so it's about 6 minutes old, that call. And you can see the address, the type of call that it was. It was for an automobile alarm, and the latitude and longitude, along with an incident number, which could be tied later to potentially tied later to Seattle crime incident reports. So let's go ahead and update the Power Pivot model. If we go ahead and hit refresh all, then we can go ahead and move over to a Power View report. And this Power View report is one way to show rich data visualizations with a tool that's very easy to develop reports in. So you can see that the date is for the most current 300 911 fire calls, and you can filter by type. So if we were to select just aid response, you'll see that everything on the whole report changes just for aid response. Let's go ahead and clear that filter. And here in the middle, you can see the count of incidents by hour. So of those last 300, what hour of the day were they happening at? And then over here, you can see a map of the city of Seattle along with some information for where each of those incidents is happening. So at this particular address in Seattle, there were 2 calls for aid response, or 2 incidents. So whatever constitutes an incident, I'm just assuming that it's 2 separate calls. Additionally, you can multi-select. So if we were to look at auto fire alarm along with aid response, you'll see that the report shows you both of those values. Now that we're in Excel, I'm going to go ahead and show you the Power Map tool. So if we go ahead and click on Insert up on the ribbon, you'll see that I have the plugin for Power Map, which is a plugin for Excel 2013 installed. And if I launch Power Map, basically it will take a look at the information that's contained here in the workbook and bring me into the initial page of the interface, and I specify what type of geographical data is included in this data set. So it's the latitude and the longitude. Click Next, and at this point you'll see that it's mapping the latitude and longitudes within the city of Seattle. So if we then take the count of incidents and make that the height, and then if we take the type and we make that category, then at this point you'll see a interactive map of the city of Seattle, where you can basically see the different types of incidents that are being recorded as calls to 911 that require service by the fire department. You can also rotate the view in order to get an angle that's a better visualization. So if we select that custom column that we created, and I didn't change the name, it's the one that we made the date time value, and drag that into the time field, then you can see how these incidents happened over time. So if we hit the play button, you can see how they added up, and up in the upper left, you'll see the time of day that these incidents were accumulating from. Additionally, we can turn it into a tour. So if we go ahead and hit play tour, you'll see how it has a full screen view of what's going on with those different incidents. And when we're in this tour, we can change some of the options on it. Let's make the effects have a 6-second duration, and let's do circle. So then if we play tour again, you'll see that basically the video circles around the actual events as they're happening and as it's going through the play cycle on the time axis. You can also then create a video and then embed that video within a presentation. So if you have a lot of information for geographical data and you'd like to show how things occurred over time, you can actually put that on a map and effectively create a video that you can embed in a presentation in order to tell a story. There's other types of visualizations you can do here too. So for example, if we wanted to just let's remove time from there for now, And if we just wanted to look at different types of visualizations for the events, so if you just wanted to see side-by-side bars or circles, or if you wanted to see a heat map to see how things are distributed, you could also use those types of visualizations. So that's an example of how you can reach out using an API to a database which is frequently updated in order to get the most recent results that are near real time. As per the definition that real time is updated every 15 minutes. I wanted to just give a few thoughts on APIs for open data. Now, APIs are great and they're used all over the place. They're fantastic for apps and they're great for small data pulls. So basically, it does limit the amount of data that you can pull in an individual query, which is fantastic for the organizations that are providing the data, because every time somebody wants to use that information, they're not downloading the entire data set and creating a large spend on bandwidth. So they're very efficient, and organizations can also track API usage. As a BI professional, APIs can be a little bit challenging, though, right? It's a situation where when you're working in BI, data mining, data science, those types of areas, you want all the data. So you can create a cube, so you can create machine learning models and things like that. And basically with APIs, multiple queries are required to get all of the data for cubes, data mining, etc. And sometimes you get APIs where there might be a limit of 1,000 values that it'll return. So more often than not, there's going to be a way to get all of the information, but when the primary way of accessing that information is an API, it can make it a little bit more challenging, and it would be nice if there was an option for anyone who's thinking of exposing a data set as open data. It would be nice if you made an option for people who want to be able to access or download all of the data in order to use it in business intelligence type solutions. Let's move on to our third demo, which is going to show you how to take different open data sets from different places that have a few common attributes and to mash them up for a reporting solution inside of Power Pivot. So the first open data set which is being used is the City of Chicago Crimes 2001 to present. I'll go ahead and click on that link. You can see this is also a Socrata portal. It is for the City of Chicago. And if you look at the data that's here in the preview mode, you can see that there's a lot of different attributes, and each row represents one crime. And this data goes all the way back to 2001. There are several million rows of information that you're able to access, and it can also be accessed in a very similar way that the Seattle 911 fire data was able to be accessed. There's an API, there's an OData feed, and you can also download the entire data set. For this particular demonstration, I downloaded the entire data set as a CSV file because we wanted to be able to pull all the information in order to do a mashup. You will see that one of the important columns here that I'll come across later and will circle back to is community area. You can see that it has a community area column that lists the area where the crime happened by number. That will be something which we'll use to tie to another data set a little bit down the road here. The second open data set which we'll be using is weather data. There's different places you can go to get weather data, and it's available at different levels of granularity. You can get it from NOAA. It is there, and you can make a request and get that data. The CDC also has a good place to go and get weather data. Their Wonder database has some weather data available that you can download. The intent is to use it along with healthcare data in order to see the effects of weather changes upon different types of health outcomes. You can see that there's lots of different stations that you can get information from, different grains, whether it be hourly, daily, and different types of attributes such as the temperature, such as heat index, and some different ways of looking at how the weather is changing. Moving back to the presentation, the third open data set that we're pulling in is census data. It's selected socioeconomic indicators in Chicago for 2008 to 2012. We can take a look at that link real quick. And that, once again, looks very similar to the other Chicago data set. And you'll see here that there's a column for community area number, and that matches up to the community area in the City of Chicago police data. So this data set, you'll see you have attributes such as percent of housing that's crowded, percent age 16 and over who are unemployed, and you have it by neighborhood with the neighborhood name. So this data was also pulled into the solution so that we can look at crime by different types of socioeconomic indicators, and additionally by the actual community area name. Finally on the list, I did create a custom date dimension and time dimension, and these basically just are used to tie the different data sets together at the level, at the green of either date or time in a star schema format. There's a couple idiosyncrasies in the data that I should note before moving forward. First of all, I only used weather data for Chicago Midway Airport. I put this whole presentation together in a couple of days, and I didn't really want to take the time to add weather from different weather stations within Chicago. However, if you're going to use this for a formal solution, you'd probably want to map all the weather stations and basically have them best represent the community areas as well as possible. It is possible that there could be changes in temperature from community areas that are along Lake Michigan versus those that are more inland. But for the purpose of this demo, I didn't do that. I just assumed that they'd be close enough that we'd still get a pretty interesting demo. The community area socioeconomic indicator census data is for 2008 through 2012. The crime data is for 2001 through 2014. So there's some data in the crime data that doesn't necessarily match up with the values that you're getting in the census data. And additionally, they're going to be at different grains because the census data is for an aggregate value from 2008 through 2012, and the crime data is on a per incident level. So it's not aggregated into that 4 or 5 year span. Additionally, there's population data that I have in the community areas, and that's 2 separate columns, and those are for the year 2000 and the year 2010. So you will see that as I put these reports together, that all attempts were made to account for the slightly offset years. Actually, the data which is for those particular years really doesn't play into much of what we'll be looking at here. But when I do use it, you'll see that I tried to make an attempt to account for those slight idiosyncrasies in how the different dates are lining up. And this is actually a good question that we should think about, is how do you determine whether data with idiosyncrasies should be compared? Within an organization, you might have one source system that's at the level of hour, and you might have another that's at the level of an individual day. Well, at what point do you say that the data is too different to compare? In an organization, that's usually just fine. But if you're talking different years, is that still okay? Or is it dependent on the type of data that you're looking at? So I think that's a good conversation to have. And I'm not trying to make a claim one way or the other. I just thought that these were some interesting data sets to use for a demonstration. And if this does spark up a good debate on that topic, hit me up on Twitter or shoot me an email, and I'd love to talk about it. First, we'll find, define, and analyze the data. We'll go through this pretty quickly. Next, we'll pull it into Excel using Power Pivot and Power Query. We'll architect the conform model in Power Pivot. We'll just go ahead and review what's already been done and explore the data in Excel, create some dashboards and reports, look for the trends and relationships in the data by slicing and dicing the business intelligence reports and dashboards, and evaluate the data for additional analysis using distribution charts, control charts, and Pareto charts in Excel. This will make more sense when we get to it, but basically once we find some things that we think are interesting in the data mashup, we'll use some statistical style tools in order to look at the data and see if it's normally distributed and whether you can run more advanced tools on it. Then we'll create a machine learning model in Azure ML. Azure ML is a new machine learning technology available from Microsoft, and we'll train and test that model and basically take the results of testing data within that model and take a look at it in Excel to see how accurate crime trends can be forecasted based upon weather data. So the idea here is there a correlation between crime and what the weather is in Chicago. So before we start the demo, I want to note that while it has some entertaining implications, it's just a demo, and please don't draw any conclusions from it. I don't know the accuracy of the underlying open data sets for crime or weather. I'm assuming the data is good, but I am not one of the persons who curates that information, so I don't really know. Secondly, I just created this in a few days and there's been no peer review. So this is a demo that I'm putting together to show how you can use these tools within the Microsoft BI stack to do some very interesting things with information from different sources. I'm not trying to make any claims or come to any conclusions. Also, it's important to note, because I know if I don't bring this up, it'll probably be mentioned by somebody, that correlation does not equal causation. So in the reports we're showing, if weather and crime rates correlate, it does not mean that we're trying to say, or that I'm trying to say that one causes the other. Weather might not cause crime rates to change, just as crime rates are not going to cause the weather to change. However, it is possible that they correlate and move together. For example, if beer sales are up at Minneapolis restaurants whenever bratwurst sales are up at Target Field in October, there's a correlation. But the cause might be something totally separate and different, such as the Twins making the playoffs. So the beer sales didn't cause the bratwurst sales, but the two tend to go up and down together based upon something else which might not even be looked at. Same thing goes with the analysis we're looking at. We're looking at crime and weather and some socioeconomic indicators, but we're not trying to say that one thing causes another. We're just looking at whether they move together. Here in Excel, if you look up to the ribbon, you'll see that we have the Power Pivot plugin enabled. Moving to the Power Pivot window, you'll see that the open data has already been pulled into Power Pivot. Down here at the bottom, you'll see that the Chicago crime data 2001 to present has about 5.5 million rows crunched into Power Pivot within Excel. We also have the date table, the time table, both of which we created in Excel in order to match the data set, the census socioeconomic indicator data, and then also the weather data. And what you can do here in Power Pivot is basically create calculations down here on the calculation bar in order to start doing some different types of math on the information that's contained within the data. So here we've created a calculation for crime count. We have arrest percent. If we were to move to the weather data, you have the average max temp. So there's a lot of different things that you can bring in and that you can start to create here in the model. And as far as relating the data, if we move to the diagram view, you'll see that we have the crime incidence along with the daily weather value over here, the daily weather values. We have the census socioeconomic data, have the time dimension, and also the date dimension. I did do a little cheat here for the demo, which is I snowflaked the weather off of the date dimension because they're both actually at the exact same grain for the demo. If you were to do a production solution, you'd want to do it a little bit differently. I'll walk you through that real quick. So here's the architecture which I put together for the demo. As you can see, Chicago crime, weather, and the community areas are all pulled in as open data, and then I created date and time in Excel, hence the green color. The Chicago crime data has the foreign keys, which point to the primary keys for date, time, and census data. And because there is 1 day in the date table for every 1 day in the weather table, since I only took data from Midway Airport, we can then snowflake the weather data onto the date table in order to do a BI solution. Now, if we were to do this in a production environment, you'd want it to look more like this. So you may have more than one weather station within the weather table. So you'd want to basically have an architecture which accounts for that. Effectively, you'd want to add a community area to each weather station in order to account for what community area weather station is within. Additionally, you'll notice that the timetable with a daily architecture for weather data can't hook up to the weather table, but there is hourly weather data out there if you wanted to go get it for more detailed analysis, and then you could probably get much better and more detailed results from your analysis if you have a more accurate portrayal of how the weather is changing throughout the day. So from here in Power Pivot, we can move to Excel, where I can demonstrate how the Power Pivot model actually ties the data together. So if we pull the crime count from the Chicago open data into the values, And then we go ahead and move down to the date dimension where we snowflaked in the average maximum temperature. You can see that both values are now in the same pivot table. And we can go ahead and also pull in the year as a filter. And if you wanted to, you could select just a couple of those years. So let's just look at, for example, 2004, 2005, 2006, and you'll see the values change. And then if we wanted to pull in the month, we can go ahead and add that on rows, and you'll see that the data is fully tied together and can be viewed in one pivot table. Now, once we have a data model like that, you can start doing some more interactive value-added charts. So if we want to look at a scatter chart here in Power View, you'll see that we have a slicer for the years here in the upper left. We have a primary type of crime down here in the lower left, and we can clear that filter if we want, or we could select an individual value in order to see how things change. On the y-axis, we have a count of crimes, and on the x-axis, we have the arrest percentage. The deciles up here in the upper right are unemployment deciles. So number 1 is up to 10% unemployment, and the blue bubbles are for up to 40% unemployment. So you can see how the different neighborhoods respond to different types of crime. Austin has a very high crime count for the number of arsons, and it also has an arrest percent of 12.32% and a hardship index of 73. The hardship index is basically from the census data. The higher the number, the more poverty-stricken the area is, the higher the unemployment. Those types of things were factored into that number. If we were to look at homicides, for example, you'll see that the distribution changes a little bit, and that the blue and the red areas that have higher unemployment also have higher crimes when looking at homicides. We could also take a look at a map, since there is geodata encoded within the solution, and you can see that right now it's selected at arson for aggregated. We could switch to attempted arson, and it's only showing the year 2011 right now. Down at the bottom, you can see the crime count by the month and year, and also for the unemployment decile. And over on the right, you can actually see it by hour of the day. When you hover over one of these bubbles, you can also see the actual address where the crime happened, what the community area name is, and how many crimes happened there during that year at that particular address. You can also filter for only ones in which a arrest happened, and you'll see that everything on the entire chart changes. And you can also move to false and see the ones where there were no arrest. So now let's move to another workbook containing the same solution that starts to look at the relationships between crime and weather. You can see we have some slicers for year, month, community area. If we were to select an individual year, you'll see that the chart changes just for that data. The same thing goes with month. Community areas, we can look at how these relationships change for individual community areas. And you can see here on the pivot table that you have community areas, the hardship index, the per capita income, then the number of homicides, and the homicides per 100,000 people. And the 100,000 people calculation was done based on the 2010 census number. So that's something that might not necessarily apply to some of these earlier years, but in general, it'll give you a ballpark figure. And for demonstration purposes, I thought it would be valuable to put that on there, because total homicides might not be very representative of what's actually going on if one area is much larger than another, or contains a much larger population than another. Over here on the right, you'll see that we have a couple of charts that are also tied to those slicers. Up on the top, we have homicides and homicides per 100,000 people plotted against the average per capita income, which is on the x-axis. And the average per capita income is in descending order. So you'll see that as average income goes down, it appears that the total number of homicides go up in general, and homicides per 100,000 also tend to go up. Down at the bottom, you'll see homicides and homicides per 100,000 people by the hardship index, which is that figure which was on the census open data, which tries to measure how difficult life is in these different community areas. And you'll see the same sort of trend there. Moving on to the next tab, we're taking a look at homicides per 100,000 versus the hardship index. This is using Power View once again. We just have a slicer for year, And you can see that on the y-axis, homicides per 100,000 are plotted against the x-axis, which is the hardship index. And if you hover over a individual community area, the population plus minus signifies whether or not that particular community area lost population from 2000, I believe it's 2000 to 2010. So the blue bubbles were areas that actually gained population, and the red were ones that actually lost population. So you can see that the areas that have a higher homicide rate also tend to have a declining population. The bottom chart illustrates the same information, but in a bar chart rather than a scatter chart. At this point, we're just going to take a look at homicides in order to focus in and have a more specific type of analysis that we can do on a smaller data set. Moving to crime and temperature analysis, you'll see here another Excel workbook. This is all built in Excel using the Power Pivot model in the background. It's just pivot charts and pivot tables with a couple of slicers. And if we were to filter for a particular community area, you'll see that the pivot table shows the average maximum temperature in a particular year, the total number of homicides, and the total number of homicides per day. So if we open, for example, 2010, you'll see that those numbers also break out by month. You could even go down to the day level if you wanted to. Over on the right-hand side, you'll see a graph showing the average maximum temperature plotted against homicides per day by year. If we clear the filter on community areas, you can see that both of those values seem to go all over the place. And down at the bottom, it's the aggregate for the months for those same values. So you can see that there appears to be a trend where the homicides per day go up in the hotter months of the year. And once again, this is just a chart, so whether it's just a trend that we're seeing or it's a real trend, at this point we really don't know. If we were to, for example, just take a look at a couple of different community areas, you'll see that it aggregates the data for those areas, and just for those 4 areas, the same trend appears to be apparent. Moving on to a more detailed version of an Excel dashboard, you can see we have the same filters over on the left, the same slicers, and here we have a couple of KPIs. So the first one is just showing the average maximum temperature. Next is the historical average temperature. So this is the historical average temperature for all time, and then whether the average temperature for that year was above or below. Then we have total number of homicides, homicides per day, and then the historical average of homicides per day. So that's basically saying if we open up, for example, 2002, historically, what were the homicides per day for all of the Januaries in the data set? And then over here we have the historical average of homicides per day for all of time. I'll get into a little bit more about the different types of ways to look at date comparisons in a slide after showing this dashboard. Over here on the right, you'll see that we have a chart for the average maximum temperature by year versus homicides per day, and then the historical average of homicides per day for all of time. Down here you have the average temperature, maximum temperature, along with homicides per day and historical average homicides per day, and that all time. And if we were to select, for example, an individual year, so 2012, you'll see the red line and the blue line change, and that's because the blue line is now showing homicides per day just for 2012, whereas the red line is showing homicides per day for all of the comparable months within the data set. So this July on the red line is being plotted against all other Julys. And then down here at the bottom, you'll see homicides versus homicides per day by temperature grouping. So 30 would be the days that were in the 30s for the maximum temperature. 70 would be days in the 70s. And if we look at the whole data set, it does appear that on warmer days, there tends to be a higher rate of homicides per day. And the highest values there are in the 80s and 90s, which will come into play a little bit later. So this is an example of where you can use Excel to mash up data and do some deep analysis in order to start trying to find out some of the relationships that exist within the data. So as I just mentioned, I'd like to take a quick review of some of the ways that you can compare values with different date aggregations. The key here is how do you compare like to like, so you get a good baseline for a KPI that actually represents a value that you can compare another value against. So when you're looking at week of the year on columns and actual year on rows, if you're looking, say, at just week number 2, you could compare week number 2 of 2002 versus all the other weeks in 2002. But if the temperature is fluctuating amongst different weeks, that might not be such a great comparison. Additionally, you could compare week number 2 of 2002 versus all weeks in the data set. And there might be some value there if you're looking from a distribution standpoint. But once again, week number 2 of 2002 probably has some characteristics which are unique to week number 2. So to compare week number 2 of 2002 to all other week number 2s in the data set is probably going to give you your best example of whether the week was actually hotter or colder than average. So now I'd like to take a look at how the homicide crime data is distributed by community area over time. So you can see here that I've created a pivot table using the Power Pivot model within Excel with a few slicers over on the left hand side. You can see I've unselected 2014 because it's not a complete year. And basically on that pivot table you have the year, the week, the community area name, and then the number of homicides that happened within that week of that year for that community area. Now I took this data and I saved it as a CSV file, and I'll show you how we can take a look at the distribution of that data in order to better understand how it actually relates when it's in these particular aggregations. And what we're looking at now is a template that we use at my employer, GNet Group, in order to take a look at data and analyze the distribution of the information in that data. So if we move back to the Power Pivot model, right now the workbook is full of dummy data that's just kind of a placeholder, but if we select existing connections, edit, and switch over to that pivot table that we just stored. Actually, I'd said it was as a CSV file, but it's an Excel workbook. And a few of the column names were changed so that it'll slide right into this template and everything will work. Go ahead and hit OK. Now if we go up to the Design tab at the top of Power Pivot and select Table Properties, you'll see that we can also pull in Community Area. Then when we hit Save, Power Pivot will reach out to that workbook and it will pull in the data, and you'll see that there's now 53,000 rows of number of homicides by week by community area. We'll go ahead and change the parameter, which is the rename value for week number, and we'll change that from a text value to a whole number so it looks a little bit better in the reports. Let's go ahead and move back to the report. And at this point you'll see that we have the data we just pulled in within this template, and the parameter, as I mentioned, is weeks of the year 1 through 53. And on the pivot table we have different buckets for number of homicides that happened in a year for a community area. So there were 689 weeks for unique community areas in the data set where there were no homicides. Let's go ahead and add that community area slicer. And let's make sure it's connected to all of the charts. And now at this point we have a dashboard where in the upper right you can see the number of distinct measurements for homicides by measurement bucket. So there were 689 weeks for community areas that had 0 homicides, and there were 687 that had 1. And then down at the bottom you can see a distribution by week on a Pareto chart. So basically it's saying that in week 27 there were a total of 174 homicides, and the line represents the cumulative percentage for the entire data set. So if we were to select an individual community area, you'll see that everything changes for that area. Now one thing to notice on the distribution chart is just eyeballing it, it does look like the data is fairly uniformly distributed. It looks kind of like half a bell curve. So we wanted to verify that by putting the data into these buckets that we're getting something that has somewhat of a regular distribution. Let's go ahead and move on to the next tab. And on this tab, you'll see that we have those weeks as the parameter. And then on the x-axis, we also have the years. And let's say we just select the year 2012. And you'll see that on the pivot table, we have the weeks for 2012. So for week 2, the average number of homicides per day was 0.16. Baseline was 0.11. So that's for all week 2s in the entire data set, all years. And then the standard deviation, and then some Western Electric rule calculations, which is for the control chart, along with whether or not there was a violation of one standard deviation for that week. So let's go ahead and add those community areas as a slicer. Let's connect them to the control chart. And then at this point, the community area slicer will filter everything on the dashboard. So if we select Austin, you'll see that the values change for Austin. The control chart is basically plotting the number of homicides per day by year, and it's looking at it versus the standard deviations. So the first dotted line is 1 standard deviation, second is 2, third is 3. If we were to multi-select a couple of different community areas, you'll see that we get the cumulative calculations. So we're able to have multi-dimensional control charts along with calculations. If we look at just one community area, say West Garfield, you'll see that in week 8 of 2012 there was a Rule 2 violation. So if we just look at week 8, you'll see that in 2012, looking at past years, 2 of the 3 values were beyond the 2 sigma line. So that shows that for that week versus the historical values, there was a little bit of a disruption in the consistency of the pattern. Additionally, you'll see that for week 19, there was a Rule 3 violation, which means that 3 of the 4 were beyond the 1 sigma line. So you have 1, 2, 3 out of 4. And then looking further down the list, you'll also see there was a Rule 1 violation in week 27. Let's take a look at that. And that's where the value went beyond the 3 sigma line. So this is an example of where you can take large amounts of information and start analyzing whether or not the data is uniformly distributed, but then also verify that there might be some patterns within that data at a more granular level that would be valuable to bubble up to the top. So now that we've found a few things within the data that we think relate to one another, and we were able to verify that in general a lot of the homicide crime data is pretty evenly distributed, let's take it another step further. This is another pivot table which was created from the Power Pivot model in Excel, and you're looking at year, week, community area number, the average max temp for that week, and then the temp versus the historic average for that week in the entire data set. If you remember looking at one of the graphs, we noted that the days that were over 90 and 80 seemed to have higher incidence of homicide rates. So we did a count of days within each week that have either 90 plus or 80 plus days in there. And then also looking at the historical average of homicides per day for that week. And then finally, we look at for that individual week, was the number of homicides above or below the historical average for the entire data set. So this data then is basically a set of features which can be uploaded to Azure Machine Learning. So Azure ML is a new machine learning service that's relatively new from Microsoft, where you can build out data science experiments for machine learning, train the model, and then you can actually host the model in the cloud so that it can be called from applications such as SharePoint or mobile apps or however else you'd like to call that particular machine learning model. So what I've done here is I've uploaded that Chicago crime table that had those features in it we were just looking at. If I right click here, we can visualize the data that I uploaded, and you can see some of the characteristics of the individual features that we uploaded. And then I built out a model that looks for relationships in the data and trains the model to recognize those relationships. Right now I have the two-class neural network loaded in here, but the data that we'll be looking at was actually for a two-class logistic regression. I've just been doing a little bit more work since I ran the prior model. So let's go ahead and take a look at how that model scored the sample data set that we put through. So basically what we did is we split the data from the Chicago crime table into 80% and 20%. So 80% of it was used to train the model, and then the remaining 20% was used to score the model to see how good of a job it does at actually predicting whether or not the homicide rate for a particular week in a community area is going to be above or below the historical average for that week in all years. So first I should note that the Azure ML machine learning models are very easy to build. You don't have to be a data science expert. You don't even have to know how to write code in R, although you can write custom R algorithms if you'd like. But you can put together those machine learning models in a matter of hours, if not minutes, once you know what you're doing. And so it's a great way to have some rapid development of machine learning models and to test your data and to keep things moving along if you want to try to find a way to recognize relationships in your information. Now the results of that Azure ML table, I've pulled them into the Power Pivot model so that we can take a look at them, and you'll see that we have slicers for the community areas. I use the community area number to link to the community area table from the census data so that we can get the community area name as a slicer. Then we also have week and the confidence bucket. Now what the confidence bucket is on a particular measurement for a particular community area on a week, it tells you not only what the prediction was, but with what level of certainty the model thinks that it made a correct prediction. So you can see here that on the pivot table that the predictions the model made that turned out to be correct versus the actual values was 70%. So 70% of the time overall, the model was able to correctly predict whether or not for a community area in a given week, the number of homicides would be above the historical average. And now what I mean by positive negative here is that basically it predicted correctly that there would not be more homicides than there were historically. Positive positive means that it predicted correctly that there would be more homicides than average on that particular week. And then the incorrect values, negative negative, means that basically it incorrectly predicted that there would be that there would not be an increase. And negative positive means that it predicted that there would be an increase and there actually wasn't, so that it was incorrect. And overall you can see that with blue representing correct and red representing incorrect, that by community area it did a pretty good job. And as I mentioned before, this is a first cut. I didn't have any peer review or anything like that, so it's very possible that that either the model could be made better or there's also the possibility that something I did is potentially giving us better results than we should have gotten. So please keep that in mind, that this is a demo, and I'm not trying to claim that this is some kind of finalized results or something like that. Then down at the bottom, you can see on 100% bar charts by week that throughout the year the rate of correct prediction was fairly consistent. So if we switch to individual community areas, you can see you get the values for that area. It's fully slice and dice to be able to see how you did for that area. Moving to multi-selecting a few of them, you can see that the values are still pretty good. Moving on to the next tab, we'll wait for that Power View sheet to open. And here we can take a look at the community areas and by confidence interval. So you can see that with the 70% confidence interval, the machine learning algorithm predicted 100% of the time correctly that there would be a greater than average number of homicides from compared to a historical perspective. With 60% confidence, it had more positive results than negative. And moving down the line, you can see the results change accordingly. We also see those same bars by community area in order to demonstrate that, that there was some variation from location to location. Moving to the third tab down here at the bottom, we can take a look at that from a little bit different perspective. So on a scatter chart, you can see that there were quite a few basically there were quite a few positives, and we have the slicers over here. So if we're looking at 70% confidence interval, it did a good job there. And basically moving down the line, we can multi-select. So if we do 60, and then when we get to 50, that's where we run into some of the more negative positives, where it falsely predicted that there would be a greater number of homicides than the historical average. So basically, in summary, we started off with open data from different sources, and then we were able to pull it into a mashed up model, analyze it for what we perceive to be trends, and then use some more advanced techniques in order to try to determine whether or not they actually were trends, and to also make some predictions based upon those values. So ideally, if a model like this were actually put into production and was verified and went through the development process where it was determined that it was giving accurate results, you could host it in the cloud, and then you could use next week's weather forecast in order to make a crime forecast, which is a very intriguing idea. So I'm not going to show it in the video because I don't think I can rebroadcast a video from someone else. But if you go to this YouTube video, you'll see a very interesting report. I believe it's from ABC News, where they talk about how some local police forces are actually using predictive analytics in order to try to figure out when they're going to have bumps in crime and in what areas they might want to look. So it's a somewhat of a controversial field, but at the same time, imagine what a tool like this could do in the hands of a community action group, or a group that likes to go out and patrol a neighborhood in order to influence people to make good decisions. With information like this, they could potentially determine where they should go and when's a good time to get the volunteers out and about so that they can influence people to do the right thing and make the right choices. Now I'm going to move on to what I'd like to see as a future architecture for open data. So today, what we have is basically an operational data store that's different for every open data set that's out there. So you have data which you can access from data.gov, also the UK version. We talked about scientific data. Pretty soon Minneapolis is going to have their own open data out there, and these are all different sources in different places. So a lot of them have different file formats. Some are API only, some are flat files only. There are OData feeds out there, and there's a lot of other different formats and architectures which you can reach out to. So what I'd like to see in the future is to have some sort of conformed ODS, operational data store. And what that means is that the historical data would be stored in one place. It would be a physical database where it would sit. The thought here is what happens if one of these countries that's providing open data has some type of natural disaster where they lose all their servers? That data's gone. So it would be nice to have that stored as a history somewhere. Additionally, it would be in one place where you wouldn't have to worry about bandwidth issues, where everybody would be able to access it, and you wouldn't have to go searching all over the internet to find these places that host open data. I personally think it would be a fantastic nonprofit opportunity for somebody to endeavor in. Perhaps an open data wiki would be a great way to bring all of this information together. From there, you could start having a conformed data warehouse. There's been talk in the scientific community about what they call linked data, where data that's similar can be linked together. Perhaps you could start with something as simple as a couple of dimensions, like the date dimension, the time dimension, maybe zip codes, and start creating some versions of open data that have conformed values and conformed fields, so it's easy to put things together. And if that were in place, then it would be easy to basically start building better reports. So another question would be, should it be a logical database for the data warehouse, or should it actually be a physical database? Perhaps Microsoft's direct query technology would be ideal here. So you don't actually have both an ODS, which is a physical database, and a data warehouse, it's a physical database. That the direct query technology could store the schema of the open data and just reach out to the ODS whenever that data is queried. If that were possible, then the promise of open data would truly be there for the masses. So you could have integrated reports with self-service reporting, and people who are not IT folks, who don't know how to write code, could basically pull open data into reports, maybe in a pivot table format or something similar, and begin using it in the ways that it is intended to be used, in finding new ways to pull value out of this information. So where do you start? As I mentioned, an open data wiki style approach, in my opinion, would be fantastic, but that's probably going to be something that, if it happens at all, it'll take some time, where you have the standardized keys, standardized common dimensions, the Kimball methodology. Not every data set's going to conform. Many will have architectural differences, different granularities. There's going to be ones that have snowflakes. There's going to be opportunities for star schemas, and there might be some many-to-manys out there that would make things a little bit challenging. For those of you who work for organizations, how can you integrate this data into your organization's data warehouse? You might not want to pull it into the primary data warehouse for the organization, but perhaps a data mart, such as an Inman-style deployment, might be appropriate. So you have your fact tables within the organization, you have your dimension tables, including date and zip code tables. Well, some of this open data out there, you could basically link right into those dimension tables. And at that point, you could start doing some of these mashed up reports that'll bring new types of value into your organization. Some recommended data sets out there. These are just ones that I've used and that I've had some positive impressions of. The U.S. Bureau of Labor Statistics has some data out there for inflation, consumer price index, unemployment. A lot of this would be very valuable in a retail setting. It would be valuable in any type of business that is consumer based. Additionally, there's weather data out there. Almost every business on the planet is somehow affected by weather. USDA has both food price outlooks, feed and grain data. Medicare has some fantastic information out there. And gas prices, they pretty much affect everybody. As I mentioned in the bottom bullet point, I could go on for dozens of slides. There's open data sets from all over the world and all over basically the country that are valuable and would meet the unique needs of organizations. Some use case examples with weather. Almost every type of organization is potentially impacted. Economic data. Of course, this is going to be relevant to most for-profit companies and maybe probably also nonprofit companies. Crime data could be used for government, retail, security, fraud detection. Commodities data, you could use that for food and feed manufacturing, consumer spending habits, agricultural services, gas prices, that goes without saying. And then also there's Medicare data, which is very granular and very useful. And you can get claims and reimbursement by category, by hospital, by individual provider, by DRG. So there's a lot of different ways that that Medicare data would be valuable to the healthcare community. Since this is a recorded version of the video, Q&A is still welcome, but it'll have to be through either the comment section of this video, or you can reach out to me on my Twitter account or through LinkedIn.